So we're still completing the square. The stuff that we learned yesterday, we're actually still doing. We're just looking at problems that are a little bit more difficult. And so today, instead of learning a process that is more difficult, we're actually going to use Desmos to see how we can make the problems more easy, even though the problems should be more difficult. So we're going to look at converting quadratics to vertex form. And if you look at your warm-up that we just did, you'll see that in the instructions, it said complete the square. That's what this process is called. It's called completing the square to convert this problem into vertex form. So the method that we have been using is called completing the square, but our goal was to convert into vertex form. So today we're going to achieve our goal, but we're going to do it in a different way that's going to be a little bit easier for us when the problems are a little bit more difficult. Okay, so we're actually going to start with that warm-up problem so that you guys can see, oh, if Miss Rice didn't teach us completing the square, if she didn't teach us how to do this by hand, how could we have used Desmos to cheat the entire time? So we're going to take the problem, we're going to write it down. We've got y equals x squared plus 14x plus 44. And what we're going to do is we're going to get our Chromebooks out. We're going to go to Desmos. We're going to plug this into Desmos as it is. So this right here is considered to be standard form. And standard form is fine. I mean, it will give you an equation. It will graph the correct U shape for you just like you want, but it will not give you the vertex. It will not give you the transformations. And so we like to convert it into the vertex form so that if we wanted the transformations like we do on the warm-up, we could find them easily. If we wanted the vertex, we could find it easily. If we wanted to find the domain and the range, we could find those easily just by looking at the equation. We like to convert it into that vertex form because that other form is more comfortable for us. So let's go ahead and graph this on Desmos. And we're going to do this with every single problem today. So we need Desmos out for sure.
What if I use the way we stay doing instead of
you're going to like this way better. And we're about to get more difficult problems that you would not want to do the way we did the past couple days. But I can show you, but you probably won't want to. Okay, so here's the graph we did as the warm-up. What we're going to do is we're going to click on the vertex. Everyone see the vertex? Yes? Okay. We're going to write down the vertex. So on your notes underneath the problem, you're just going to write down, okay, my vertex is -7, -5. Okay. And then we're going to go back to our paper and we're going to say, oh, I know what vertex form looks like. I know that the x coordinate should be the opposite sign. I know that the y coordinate goes on the end of the equation, right? So I'm just going to write y equals x plus 7 squared minus 5, and I'm done. That's it. So this is now the vertex form. That's all you got to do. Now, this is using Desmos to cheat the system, right? So there's a reason that the past couple days I said you couldn't use Desmos. And now today I'm saying we're going to use Desmos. We're going to do more difficult problems, but we're going to make the process easier because we're going to use Desmos to cheat. Okay. So if you do the problem by hand, we know how to do that. It wasn't terrible. We were all successfully doing it for a whole worksheet yesterday, but this definitely makes the process faster, doesn't it? Yeah. Okay. So we're going to try one of the more difficult ones. And on Desmos, it's still going to be pretty easy. So the ones that we were doing in class yesterday and the day before, they always had an x squared that was by itself. Those are the more simple ones. They have an x squared that is alone, and you can just work with them like that. The ones that we're going to do today are going to have an x squared term that is not alone. 2x squared, or maybe -x squared, or maybe 1/2 x squared. They're going to have a number in front of the x squared, and that makes the problem more difficult unless you're using Desmos, and then the problem is not difficult at all. Okay, so before we even get started, circle the number in front of the x squared because that's going to show up in our final answer. We need to circle that. We need to remember that for the end answer. Okay, now I'm going to go back to Desmos. I'm going to type this in on Desmos, and I'm going to see what my vertex is, because if I'm putting this in a vertex form, I need to know the vertex. So 2x squared minus 16x plus 33. So I'm going to go over here. My vertex is 4, 1. So I'm going to write that down. My vertex is 4, 1. Okay. And so now I have that number in the front, and this number in the front is still going to need to be in the front of my equation when it's in vertex form. This is a vertical stretch of 2. And so I still need to have a vertical stretch of 2 in my equation. So I'm going to write y equals, and I'm going to do this part, but I'm going to have the 2 in the front. Vertical stretch of 2, and then I'm going to write my vertex. X minus 4, because I have to change the sign for the x. And then I'm going to stick a plus 1 on the end. There's my vertex form. Does it make you kind of mad about the last 2 days? Don't be mad. You know a lot of math now. Okay, let's try another one. We're going to do y equals negative x squared plus 6x minus 5. So this one does not have a number in the front, but it does have a negative in the front. It's a reflect over x. So I'm going to circle the negative because I might not have a number that I have to put in the front, but I am going to have to carry that negative for the front. All right. Now, if you're wondering, if you want to make sure that you got the answer right, the cool thing about this is you can graph the original problem, which we already did, and then you can graph your answer to make sure that your answer graphs the exact same way. So we can try that on this next problem and just make sure that we got it right. So I'm going to type in the original problem, y equals negative x squared plus 6x minus 5. And there's my vertex, 3, 4. So I'm going to write that down. Vertex is 3, 4. Okay. So let me go back to my notes. So I know I'm going to have a negative in the front. I know my vertex is 3, 4. And so what should I be writing for my equation? Okay. And now if I want to check to see if this answer is right, I just need to plug this one in and make sure it graphs exactly the same way as the first problem did. So I'm just going to go back to Desmos and type that answer in that I just got. Y equals negative x minus 3 squared plus 4. And as you can see, it's the exact same graph as the first one, and that means that I got the answer right. So you can even check your work as you go. I don't even have to make an answer key for this because you can know as soon as you did the problem, yep, I got it right, let's move on. Does that make sense? Perfect. Okay. So we're going to feel really good about these as we go throughout the assignment today because they're quick, they're easy. We don't have to do a lot of mental math. We can just type things in and figure the problems out. So I want you guys to try this one on your own and see if we can come up with the right answer. We're going to do y equals negative 2x squared plus 12x minus 17. Y equals negative 2x squared plus 12x minus 17. And I want you guys to see if you can come up with the correct equation.
Are you looking at?
Yeah, we're gonna figure it out. But you'll know if you got the answer right because you can just graph your answer and see if it's the same. Anyone want to share what they got? Perfect. All right. Seem like we can do those? Yeah. Perfect. Okay, so I'm going to hand out the assignment. It's kind of like yesterday where it's got the problems first where you're actually going to be writing the equations, and then it's got some problems at the end where you're going to be finding, you know, max and mins and domain and range and x-intercepts, because I know those are your favorites, so I did not want to leave you guys hanging. I wanted to make sure that you had some of your favorites. Caitlin personally requested them. She said, Miss Rice, please, please, please give us more of these. The warm-up is not enough. I need at least double, triple that amount of problems. And I said, Caitlin, you got it. I will do exactly that. So let's thank Caitlin. Caitlin, thank you. Thank you for the request. I will make sure to give you as many of those problems as you want. Give the whole class really as many of those problems as you want. So, all right. Let me pause this.